This is Sunita from Department of Chemistry, Satyabama Institute of Science and Technology. Today I am here to talk about one of the practical session which is useful for the BE/BTech students who is pursuing first year, first semester or second semester chemistry laboratory experiments. So we have so many experiments like EDTA, glycine, pH, iron, etc. Among all these things, so I am going to perform estimation of strength of HCl by pH meter. So pH is nothing but negative logarithm of H plus ion concentration. So pH is equal to minus log base 10 H plus ion concentration. So why we are measuring the pH of a solution? So pH will give you the hydrogen ion concentration present in the solution. So our experiment is nothing but determination of strength of acid present in a solution. So we are not directly measuring the H plus ion, we are measuring the pH of a solution, so which will correlate and which will give you the how much amount of H plus ions present in a solution. So that is what we are going to measure in this experiment. The experiment is called estimation of the strength of HCl solution by pH metry. So what is pH? So pH is nothing but minus log of base 10 H plus ion concentration. Clear? Now, so for measuring this, what are all the apparatus we require means, so we require glass, electrode, pH meter, sodium hydroxide, HCl, burette, beaker, etc. A glass electrode is a one. It is an ion selective electrode which measures the H plus ion concentration present in the solution. So it is made up of a glass, and at the bottom you will have I will show you, you will have a glass, and inside which it was filled up with a KCl solution having silver electrode. Now by using all these things, so we are going to measure the H plus ion concentration present in the given HCl solution. So what we are going to do, so this is not like simple acid base titration. See, we can estimate the amount of HCl present in a solution by simple acid base titration, but what is the advantages of this pH titration over volumetric titration is, volumetric titration as a human we are doing, we may commit some mistakes that we can rectify, and no need of use any indicator. So it's an instrument, it is going to give the all the values, so it may be like it will be accurate and precise value you will get, because we are going to calculate the endpoint only from the graph which we are going to plot. Here we won't perform like ordinary volumetric titration as titration 1 and titration 2. Here only one titration. So what we are going to do, so we are going to measure the pH of a solution. So this is volume of sodium hydroxide, and we will measure pH of the solution. So how we are going to measure? By adding sodium hydroxide from the burette to the HCl ion solution. Where we are going to take? We are going to take in the beaker. So with this we are going to perform the titration and we will measure the endpoint. So we are not going to calculate the amount also, we are going to calculate only the strength. The strength present in the strength of the H plus ion present in the HCl solution by using pH meter. So now I will show you the demonstration. So after showing the demonstration, I will take all the values and I will tabulate all the values. So with that values, I will draw the graph. So once you see the graph, then you can calculate the endpoint. Then at last we will complete with these calculations. Clear? So now let us start the demo class for pH titration by pH meter. First, before you start any experiment in the chemistry laboratory, so you have to first wash all the equipment, whatever you are going to use inside the chemistry laboratory by tap water and rinse it with distilled water. Keep that in mind. You have to collect, this is called wash bottle. Only in this wash bottle you will collect all the distilled water. Now I am going to take the sodium hydroxide. So for this titration you require only two solutions. One is called PHHCl, it will be marked in the laboratory, and the second one is PH sodium hydroxide. So what I am going to do, I am going to take this sodium hydroxide in this burette after washing, and I am going to make up this HCl solution in this 100 ml standard flask. So first what I am going to do is I will wash all the apparatus whichever I am going to use. First the burette. So burette has to be washed with distilled water. Why you have to wash means because any solutions, the previous batches or whomsoever it may be, they would have done, then it will contaminate your solution. So you should get the correct value. For that purpose only, so you have to wash all the apparatus. So once when you are washing, you have to wash, keep that in mind, you have to wash the nozzle point also. Clear? Then take a little amount of distilled water, shake well, and completely drain through the nozzle point. And what is the solution we are going to take in this burette? So we are going to take the sodium hydroxide, PH sodium hydroxide. So you are all a student, you should know how to fill it up. So what you have to do, first you have to keep the funnel like this. To release the pressure you have to lift, and first you add a little amount. Then rinse the burette with corresponding solution. Not only for this pH titration, whatever the experiment you are going to do it in the chemistry laboratory, so you have to rinse the burette or the pipette with the corresponding solution. Keep that in mind, and I am draining all the solution only through the nozzle point. Clear? Now keep the burette. Carefully transfer the sodium hydroxide solution. Keep that in mind, when you are transferring the sodium hydroxide solution, it should not contain any air bubble inside the burette. Yes, it's almost over. So once you fill up the solution, don't adjust for zero reading. First what you have to do, so first you have to fill the nozzle point. That is the first and foremost thing you should follow in the lab for all the experiment. So drain the solution till my nozzle does not have any air bubble. You must be knowing this is an colorless solution. For all colorless solutions, so we will be considering only the lower meniscus. So what is meant by lower meniscus? The bottom part of the curve should go and touches this zero mark. That is called lower meniscus, because you would have aware of it. And adjust the burette reading for zero marking. So when you are adjusting the burette reading, don't keep the burette like. So you have to keep the burette exactly at your eye level, otherwise it may lead to parallax error. So keep the burette at your eye level and adjust the reading for zero marking. Completed the buretting out the solution. So you have to clamp the burette in this corresponding burette stand. Now my burette solution is ready for titration. Keep it away. What did I tell? Now I am going to make up the solution. See, we will give the high concentrated solution like this. So what you have to do? You have to make it up. Why you have to make it up? Because I have some normality of sodium hydroxide. With this it has to match. So for that purpose, you should not pipette out the high concentrated solution. What you have to do? You have to dilute the solution in this 100 ml standard flask. Don't pipette out directly. So what you have to do? First, you wash this one. As usual, any apparatus in the lab, whenever you are using, first wash it with tap water and rinse it with a little amount of distilled water. All the washings for each and every experiment, whatever you perform in the lab, you have to follow. Clear? Then take the funnel, wash it off, because I have used the sodium hydroxide. Keep it like this. This is called glass rod. Wash it off. See? Hold the glass rod like this. It's all depending upon whether you're left-handed or right-handed. So I mean right-handed, so I will hold the glass rod in the left hand and carefully transfer the given pH solution into this 100 ml standard flask. Don't allow even a single drop to fall outside. Is it clear? Because one drop outside, your mouth will also be outside only. Okay? Don't take your left hand, take distilled water, add little. Then rinse. Transfer the solution. So when the solution is not draining, what you have to do? So you have to adjust the funnel to release the pressure. So second time, rinse, transfer. Then third time. 2 times or 3 times, that is more than sufficient. So any amount of the solution which sticks inside this small bottle will be transferred thoroughly. Is it clear? Now keep this bottle away. See, drain the solution by releasing the pressure. Now wash the glass rod. Now only I have to take my left hand, keep it here and wash the mouth of the funnel and as well as stem of the funnel. Okay, you see how many washings I have done, and all my washings has come below the neck of the standard flask. So you should not keep the funnel and you should not keep on water, then it may lead to excess. So now what you have to do, take the pipette, open this wash bottle. Before you use anything, as I told you, you need to wash. Now pipette out the solution, distilled water. Now this is the standard flask. Here only you have the mark. Exactly up to this level you have to add the distilled water. See, you can add directly. Sometimes what will happen means you may add excess. Again you have to pour the solution. Then strength will not be correct. So don't do any exercise inside the lab. Take the pipette, add drop wise like this. See, now when you are nearing that marking, what you have to do, you should add drop wise. Clear? Now see, again this is also a colorless solution. What meniscus I am following? Lower meniscus. Close this by using the lid and shake well for uniform concentration. So you have to shake the solution because down you have the HCl solution, above you have added water. So all should be uniform. For that purpose only what we are doing, you are shaking the solution for uniform concentration. Keep that in mind. The given pH solution in a small bottle, you have to make it up in this 100 ml standard flask. Without making up, if you keep it out, it will not be exactly 20 ml. If you do like this, definitely it will be a mistake. Is it clear? Now shake well, ups and downs at least for 10 times. Clear? Now after shaking, some solution may fall. Don't bother about this. Then again, no need to add. Already we have done it. No need to add it again. Is it clear? So after shaking, well it will not be up, it will be coming down. No need to worry. Then what you have to do, take the 100 ml beaker. So as I told you, you have to wash. So from this solution, you have to pip it out exactly 20 ml.